Hello and welcome. In today's video, we are going to solve question number 16. Just in case you want to give the question a try, pause the video and try solving the problem. When you are done, play the video to see my own method of solving the problem. Grab yourself a bottle of water or a bottle of juice and let's proceed with the solution to this problem in 1, 2, 3, go. Solve the differential equation dy over 1 plus 2 sin y plus cos y equals to dx over 3 plus 2 sin x plus cos x. In this case, we do not need to separate the variables since the variables are already separated. All we need to do is to proceed to solve the problem by integrating both sides. But the problem here is to perform the integration, which is something that is challenging. But do not worry, we are here to help you. So to integrate this problem, we have to use something called magic substitution or Weierstrass substitution, or what you call the substitution of the trigonometric function. If you have an integral of this form, you can always solve this integral by doing the substitution. We are going to use these two identities and replace them for the value of sin y and cos y and simplify the problem. So we'll go right ahead and put the integral sign on both sides and try to evaluate the problem. So go right ahead and replace. We have the integral of dy all divided by 1 plus 2. What is sin y? Sin y is 2 tangent y over 2 all divided by 1 plus tangent square y over 2 plus cos y. Cos y is 1 minus tangent square y over 2 all divided by 1 plus tangent square y over 2. And this equals to the integral of dx all divided by 3 plus 2. What is sin x? Sin x is 2 tangent x over 2 all divided by 1 plus tangent square x over 2. This sin x plus cos x is 1 minus tangent square x over 2 all divided by 1 plus tangent square x over 2. Once we've done this, we'll go right ahead and simplify. The least common denominator for this entire expression under here is 1 plus tangent square y over 2. So I'm going to multiply this by this. I'm going to have the integral of dy all divided by. So this time this is 1 plus tangent square y over 2. And then plus 2 times 2 is 4 tangent y over 2 plus, and this is going to cancel out obviously, so it's just going to be 1 minus tangent square y over 2 and all divided by the least common denominator, which is 1 plus tangent square y over 2. And this is equals to, we do the exact same thing here. We find the least common denominator and then we'll go ahead to simplify. So this is the least common denominator. So we just have the integral of dx. So this times this is 3 plus 3 tangent square x over 2 plus this time this is 4 tangent x over 2 plus 1 minus tangent square x over 2, 1 plus tangent square x over 2. Once we've done that, we'll realize that this will go in the numerator. So this goes in the numerator, but remember 1 plus tangent square y over 2 is secant square y over 2. So we have integral of secant square y over 2 all divided by, now I can collect leg terms here. So if I do that, what I observe is that tangent square y over 2 will cancel out tangent square y over 2 right here. Then I'm going to have 4 tangent y over 2 plus 1. So it's 4 tangent y over 2 plus 1 equals to 1 plus tangent square s over 2 is actually secant s over 2. And if this goes in the numerator, it becomes the integral of secant square s over 2 all divided by, I can simplify here. So 3 tangent square s over 2 minus tangent square s over 2 is 2 tangent square s over 2. And I just have 4 tangent s over 2 plus 4 tangent x over 2. This 3 plus this 1 is 4 plus 4. Let 4 tangent y over 2 equals to some u. And yeah, I will say let tangent s over 2 equals to some new variable t. So in this case, if I differentiate this, I'm going to have 4, the derivative of tangent y over 2 is secant square y over 2 times the derivative of y over 2, which is dy over 2, equal to du. If I differentiate this, the derivative of tangent x over 2 is half secant square x over 2, and this equals to t. So I'm going right ahead to replace. Here I have secant square y over 2, but I have 2 secant square y over 2. So I'm going to just divide. I'm going to have 1 over 2, the integral of this is. So if I put a 2 secant square y over 2 here, and then I divide this by 4 tangent of y over 2 plus 1, this is going to equal. So secant square s over 2 dx is 2 dt. So it's 2 dt all divided by, this is 2t square plus, this is 4t plus 4. And I'm going to replace now. I'm going to have half the integral of 2 secant square y over 2 dy du. So this is du all over 4 tangent y over 2 is just u. So this is u plus 1. And then this is equals to the integral of, if I factor out a 2 from here, this 2 and this 2 will cancel out. So I'll have dt all divided by t square plus 2t plus 2. The integral of du over u plus 1 is just the ln of u plus 1. So this is half the ln of u plus 1 equals, I'm going to complete the square on here. So I'm going to have the integral of dt all divided by t square plus 2t plus 1, and I write a plus 1. So it's half the ln of u plus 1 equals to, this is the integral of dt over t plus 1 all square plus 1. So this entire side is tangent inverse of t plus 1. So this is half the ln of u plus 1 equals to tangent inverse of t plus 1 plus some constant c. But I know u. What is u? U is 4 tangent y over 2. So 4 tangent y over 2. And I know t. What is t? T is tangent s over 2. Tangent s over 2. So I just go right ahead and replace the value of t and that of u. And that will be my final answer. I'll have half the ln of u is 4 tangent y over 2 plus 1 equals to tangent inverse of t is tangent x over 2 plus 1 and then plus c. This, ladies and gentlemen, is the solution to this differential equation. Thank you very much for watching and see you in our next video.